All right, here we go. This is lesson 2-4. We are on. This video is for future students.
Can you just
Please tell them hi.
Yeah,
Sure. Hello from the past.
Hi, future students.
hello from the past.
Future loving AP Cal. We're the best.
Yep.
We were the first.
We make the legend.
All right, so lesson 2-4, advanced power chain rule. So we have a bunch of power types. By a bunch, I mean 2. So we have simple and complex. So simple, and these are the really easy ones. Let's do an example here. So if I do the derivative d dx of x squared, I'll put parentheses around it, x squared, that turns into 2x times, what's the derivative of the inside function? So the outside function was 2x, and then take the derivative of x, that turns into,
2.
no, just the derivative of x.
Oh, 1.
1.
Yeah, times 1. Because we already took 2. The 2 came from moving the power down. So the inside function is just the x.
Oh, because the outer would be the parentheses squared?
Exactly, yeah. So the outer is parentheses squared. So another example, I want to get 4 of these down just to make sure we have a lot of examples. So 3 times x to the 4th, 3x to the 4th. This turns into what? What is it, guys?
12x to the third.
12x to the 3rd, 12x to the 3rd,
Carly?
said by Carly, times what? What's the derivative of x?
Just 1.
Just 1. Yeah. The inside is x.
Is it ever not going to be 1?
Yeah, so 1 is like where you end with the babushka doll at the very end. It's the tiniest one. You'll always end at 1.
Oh.
Usually you don't write it.
Because the parentheses, if you were to draw them in, would be around X.
Yeah, it would be x. So inside is x. So dinner is 1, or inner is x. So let's check out d dx, the derivative of negative 5x to the negative 2. Negative 5x to the negative 2. So what does that turn into?
10x to the negative third.
10x to the negative 3rd power times, and then keep going until we hit that inner babushka doll. Times 1, exactly. And our final example, d dx of 6x to the 1/2. That turns into someone new.
3x to the negative 1?
3x to the negative 1/2. Kaylin has it. Times what?
1.
Times 1, yeah. Notice a pattern here for the simple cases. In fact, because I have technology, I can move this line over, and I can move it a little bit down to make it nice and neat. All right. So every time you have a simple power, the d dx is just the d outer. So let me write that down because that's it is important. I'm going to do this in a different color. So every time, whoa, my computer just freaked out. Every time I have a simple power, every time I have simple power, simple power,
Who the hell is starting?
I know. Well, how much is on minutes, John? Oh, yeah. Yeah, Lisa.
the derivative d dx is just
Oh my god. I'm sorry, it's just in place.
doubter.
Doubter.
Just a doubter. All right, but complex is a little bit different. And yesterday we saw examples of complex, and now we're going to formalize that process a little bit more. So let's take the d dx, the derivative of x plus 3 to the power of 2. What is that going to turn into? And you guys are doing this for me.
It's like, I'm still ready now.
Yeah, it's already.
Okay.
Okay, so the inner, or no, the outer, first of all, would just be the parentheses squared.
Yep.
Would it just be 2? The derivative of that would just be...
What?
So Joey has it. It's 2. And then in parentheses, stuff, because it's turned into a 1. You don't even have to write the 1 if you don't want to. And then the inner,
It's x plus 3.
x plus 3.
So you keep that plus 3?
So that was the first part. That was doubter. What about dinner?
And then it would be x plus 3. That's the inner.
Inner is x plus 3. I agree.
X plus 1.
1. Nice. Okay, so it can be 1, but it can also be something else. So let's check out another example. Dx of, let's try, I'm thinking 3, we'll do 4x to the power of 3 to the 4th. Try that guy.
What the heck?
So like 12.
Just wants to tackle that piece?
Tackle him, yeah.
12 to the, and then parentheses to the 3rd.
12 to the parentheses to the 3rd.
And then,
That's doubter, almost, because we have to fill in the parentheses.
then 4x 3rd.
4x to the, okay, maybe I need to give myself some more room. 4x to the 3rd went on the inside, and then this was a 3 because it went from 4 minus 1 to 3. So that's doubter. What about dinner?
12x to the power of 2.
You got it, Joy. 12x to the power of 2.
Hey.
Yeah, Joy.
And these are all being multiplied. I'm not going to write the multiplication sign anymore. You should always know that these are being multiplied. So now you can have a doubter and a dinner where the dinner is not necessarily 1. All right, let's try another one. Dx of, I'm thinking a harder one. Let's try negative 5. Study groups are a great time to try to make your own up and see if you can solve them. It leads to really cool questions.
I would do a study group every day, but we have to like run and go to volleyball and go to the orthodontists and like.
Yeah, I know. We have lots of things. X squared minus x, and I'm going to do all of that to the power of negative 2. So all of this is the derivative. So I could put giant brackets here to say all of that is the power, or all of this is being the derivative.
Yeah, can we just ignore complex?
The thing is, you're probably mostly going to see complex when we're
How did I know
doing
that?
calculus. So,
Life is all complex.
all right, help us out. What is it going to be? I need doubter and dinner.
10.
10,
10.
Times x squared minus x.
and then you're just going to leave the inside x squared minus x
To the minus 3.
to the minus 3. Okay, we have doubter, and I'm going to run out of room here, so I'm going to write underneath here, but this is being multiplied. I'm multiplying this by what's underneath here, by dinner. What's our dinner? We have x,
2x.
2s,
X?
2x,
Oh, wait. 2x minus 1.
2x minus 1 I hear. Is that right?
Yeah.
Yeah, it is right. 2x minus 1, there's our dinner.
Why are you doubting me, Mr. Smith?
I don't like dinner.
He's a doubter. We're dinners. We're in.
All right. I'll set this guy up. I want you guys to write it down. Dx, the derivative of, I'm feeling another square root coming.
God. Ew.
I'm not feeling it.
Me either.
We're not feeling it, sorry.
I think you're wrong. Mom?
If you notice the pattern, look at what's happening on the left compared to the right.
No.
3 minus x to the power of 3. And all that is to the 1/2. Do you guys see the relationship between the left-hand side and the right-hand side? Left-hand side, right-hand side, left-hand side,
No.
right-hand side?
It's negative 2. 4. 2. And a half.
Go ahead and write it down.
So 3 times 3 minus x cubed to negative 1/2.
We'll see if everyone else gets that.
Oh, well then I'm supposed to say that.
Yeah, we're just letting everyone do it on their own. Again, I'm running out of room. I'm going to start writing over here so that I have everything. So I heard a 3 from Kaylin. 3 times 3 minus x cubed. And what power did you take this to? Negative 1/2. All right. Did everyone else get this doubter?
Yes.
What'd you guys get for dinner?
I get 3x squared.
3x squared?
Negative.
Isn't it? Yeah.
Negative 3? Is it positive 3?
It's negative.
It is negative. You're right. Negative 3x
Don't
squared.
try and trick us.
Would it be 1 minus, or you just get, no, because there's no x there. My bad.
Yeah, technically all of these you could even write after your dinner a 1 because that's the inner Marushka doll. You always end our
Do
babushka
we
doll.
have to?
You don't have to, no, because you know that that is there. The derivative of just x, which is now the inner, if you think about it that way, is 1. So you end with just the inner.
So, do we have to, that is the answer, right? Like, we don't have to multiply them?
That's the answer. Yeah, I mean you could multiply them and simplify this one even further.
Okay, really.
And that would just be negative 9, and then I just write the rest of this. 3 minus x cubed to the negative 1/2 times x squared.
Make us simplify on the AP test? Or
No,
is
okay,
it-
so that's a really good question. So generally speaking, never simplify unless you are 100% sure you can simplify.
Oh, look.
If they say in the instructions that you need to simplify, then unfortunately you are bound by those rules. But generally speaking, generally speaking, just don't simplify. You'll lose points if you try to simplify and you make a mistake. So by simplifying, you are opening yourself up to losing points when you don't have to simplify.
So, like, if there's an answer of, like, the simplified and non-simplified? Or is that not gonna happen?
Oh yeah, so if it's a multiple choice, then you'll probably have to simplify to find what those choices are.
That's
Usually,
because like in the test that we had last time, it was like I circled the answer because like that was the one before I took my last step, and it was wrong. Like I didn't simplify, and that option was there.
Yeah, like,
oh yeah, so then you have to make sure that you simplify.
oh, God.
All right, so our last thing that we're learning today is quotienting.
Wait, what's the rule below? You have to have a rule below the other one.
Rule below is just keep going. So keep taking inner and inner. So you might for complex you will have a dinner and even. Okay, my pen just really is not liking me right now. It's not a pen, it's a stylus.
First day, your notes are amazing.
So
Like,
good.
They have improved a lot. That's
they-
good.
I can
Did
read.
you save those old notes?
Yeah. Do you guys want to see them?
Yeah.
Okay.
That's
After.
especially writing all those
What
numbers,
is
like,
going
it
on?
So,
looks
future
super good.
student who's listening right now, you're lucky Mr. Sindel has improved because
Yeah, we couldn't read him.
it was rough.
And possibly dinner inner.
That was my chair.
I was like,
No, she's lying.
That was my
it
chair.
was funny because the car said, "Excuse me," and I was like, "Okay."
I said excuse you.
Oh.
All right. I am going to the next slide. Are we ready?
Yep.
All right.
Oh yeah.
Here we go. Let's set this guy up. Set him up. I'm gonna call this n quotienting.
Wait, can I
N.
ask you a question?
Go for it.
Can they hear me?
Yes.
Like it's a good microphone. Like it picks up.
So before I had my microphone on the setting where it was, I forget the actual term, but it's only picking up sound from the front, and I just switched it this morning so it picks up sound from all 4 directions. So they should hear you.
They hear my chair fart.
Yeah, they heard Kaylin fart. Okay, so
I didn't.
so let's move on to n quotienting.
For the record,
So did they hear my chair fart?
so if I go over to that corner and fart, they won't hear me.
I'm gonna like run it.
Oh my god.
Quotient. Quotient. That means something, but we'll get to that in a sec.
Bless you.
That was a cough.
No, that was a fart actually.
G of x. That's going to be equal to 4 all divided by x squared minus 2 to the power of 2. That's
Is
gonna.
it negative g of x?
That's just a bullet point.
Oh, okay.
And our next bullet point is going to be g prime of x, the derivative of that function. I also want to have an h of x. a little bullet point. You can just do a little point if you want.
How much room should we need?
We need an h of x and an h prime of x, and we're done with the notes. H of x and an h prime of x, and then your summary is going to go underneath here. So down here is your summary. I'm going to make the h of x for this one, our new function. I'm going to make it negative square root of 3 minus 2x. So 2 minus 3x to the power of 4, and then we're going to square root that guy. Square root of that guy equals. Okay, there's the setup. Copy it down, and then we'll knock it down. Well, it was the same word. Copy it down, knock it down. I wish I could get the credit for that. And quotienting. So if you have finished the notes, think about the word quotient. What does that make you think of?
Isn't that like division?
Yeah.
Division, yeah, there it is. Division, and more specifically, in our case, a fraction.
It makes me think about Miss Silker yelling at us.
Oh.
A fraction.
I remember she like comes.
Because a quotient,
Now, Kale. She
a
could-
quotient is just a fraction.
He like shows it at one of the meetings, and it's like Miss Silker's like,
Like, she has like a meeting with you. Like,
I need to talk to you.
So the main takeaway here,
Wait, why'd you erase the star?
because I want to make it a different color. The main takeaway here is that I want to make a fraction not a fraction. So make the quotient, make it, and when I say it, I'm talking about the fraction. So maybe you want to do an arrow here. Make it not a fraction. And our title down here, I should have set this up. I forgot to set it up. But our title down here is N radicline.
That's radical.
It's pretty radical. Radical-ine. And
Wait,
radical,
So that should go for the H of X?
yeah, that's for the h of x. Radical,
I ran out of room.
radical means what?
It's when you disagree with
Yeah, the
like,
radical.
a radical
group.
terrorist, a radical student.
That is one of the definitions of radical. I totally agree. In math, what does radical mean?
That was a high five.
I can't remember.
Isn't it like when something's squared root?
That's it, square root.
Radical.
N radicline. All right. So N quotienting. I want to turn this fraction into a not fraction because there is a rule for taking the derivative of a fraction, but if you can get around not using it, then that just makes your life so much easier because then you're just using what we know. I don't want to have to teach you another rule for a quotient unless you really need it, and I'll talk about that in, I think it's lesson 9. It's one of the end lessons of this unit, actually. So how do I make this fraction into not a fraction? And it has to deal with negative exponents. What do you guys think?
So you put 4 times x squared minus 2 to the negative square.
Yep, you have it. And you said it a little bit off. It's to the negative second power or negative square.
Well,
Negative
that's
square isn't really the best way of writing it.
Negative 2
But yeah, so Sophia has it. You rewrite it. The numerator is 4, and I'm going to write this binomial as a term in the numerator. I'm going to bring it up to the top by writing x squared minus 2. I bring it up top.
You good?
There's nothing on the bottom. And instead of writing a positive 2 power, I'm going to do a negative 2 power.
You want some water?
Because now I can take the derivative. Go ahead and write the derivative. I will catch up to you guys. Don't shout it out, Kaylin. Don't shout it out. Go ahead and do the problem, and I'll catch up to you guys.
Caleb.
You've been called out a lot
like
today.
twice by teachers today.
What is the derivative? We need doubter and dinner.
Wait, so what are we finding the derivative of?
I want to find the derivative of g of x. I want to find the derivative of this fraction, and I helped you rewrite that fraction in a better way. Better is relative, I guess. It's better because I don't have to use a quotient rule, which we haven't learned yet. So you following along in the video, I'm talking to you. You write this now.
I hope that whoever watches this video like laughs really hard and like is like that was a
Everyone
cool
was
class.
like, this is so lame. I'm so
But
glad
it-
They
we
can
did
still hear us.
It's gonna be funny though because of like what I farted.
All right.
You did. You farted.
She admitted
I
it.
did
On the
not.
record.
It's on record.
On the record.
All right, so go ahead. I want Isabel. Tell me what this derivative is.
Okay, so
Negative 8,
I wanna see something
Parentheses.
satisfying.
parentheses,
X squared minus 2.
x squared minus 2,
Ready?
Parentheses.
and parentheses,
Minus 3.
Oh, it is
minus
so
3.
good.
Like it goes together perfect.
Yeah.
Nice. All right, do we all agree? This is the derivative?
Yes.
Yeah. Well, no, wait. We need dinner.
We need dinner? Yeah, we got doubter. We need dinner.
So
What's
that
dinner?
is 2x.
2x.
2x. So we need to multiply that all by 2x.
2x.
Exactly. So if I were simplifying, if I'm in the mood to simplify, which
I'm not.
I am going to simplify for my class, we're going to do this. Someone do this for me. Can you please do this? Can you shout it out?
Wait, what do you? I don't.
Simplify this.
16x
Minus 16x.
I'm not super fine.
parentheses x squared minus 2 raised to the power of negative 3.
Perfect. So the rule here in terms of how I want you to simplify, if you're in my class and you're not on the AP test in May 15th or whatever it is this year, if you're in my class, simplify. I want to teach you to simplify, but on the AP test, don't simplify.
Unless it's multiple choice and they give you
Exactly.
non-simplified and simplified, then you should choose the simplified.
So on the AP test, they shouldn't have an unsimplified and simplified version because both of those should be correct. I don't
Okay.
know exactly the case that Carly's talking about. Maybe I can talk to you after class about that problem.
No, I feel like I got that one too, but maybe I was
It was in
wrong.
our pre-test.
I think I was wrong about like how you could simplify it. Or, like,
There should have been an error in the unsimplified version.
but I do remember that one. Every time.
All right, so keep simplifying for us. There's only one time of the entire year that you're allowed to not simplify, and that's a ways away, so keep simplifying. All right, how are we going to write this radical as a power?
So,
Raise it all to the negative 1/2.
or just the. Oh yeah, no, positive 1/2.
All right, so just making sure that the microphone picked it up.
Yeah, I don't know why I said negative.
We said negative 1/2 power or positive 1/2. So, all right, let's give this to Rosalie.
Ah, wait, I wasn't. I was ready to.
Class, Rosalie, Rosalie, class. Sorry.
I want to rewrite this in terms of a radical.
Oh, okay. So you do the whole thing, but you do it to the 1/2.
Whole thing to the 1/2. Tell me exactly what to write.
Okay, so parentheses,
Parentheses,
2 minus 3x to the 4th power,
3x to the 4th power,
parentheses,
and the parenthesis
to the 1/2.
to the 1/2.
Negative.
And then you keep the negative outside the parentheses.
Oh yeah, so like negative
Or in.
1 outside.
Do I, yeah, where do I put it?
Right there.
Just, okay, so like that? Is everyone in agreement? All right, I agree. Good job, Rosalie. You have an applause.
Thank you, thank you.
All right, now find the derivative. What are the two things I'm looking for?
Dinner and doubter. Doubter and dinner.
Doubter and then dinner. The reason I know I'm going to be looking for dinner is because I have what? What are we calling these things on the right-hand side?
Hunger.
Complex.
I'm just kidding.
It's a complex equation in this case. Thank you.
He's like, why am I looking for dinner?
Yeah.
Yeah.
Good.
Rosalie did
We were
an
clapping
answer.
for
Did a
Rosalie.
really good job.
I'm super proud of all you guys.
This is our
really
principal,
hard.
Miss Sasson.
Yeah, so he's recording right now.
So for future
That's
students,
I'm really proud of everyone. This is a super hard.
That's why he has that hat.
All right.
Is this recording? You mean where it says recording?
progress.
All right.
I hope you still
Sorry,
have this
Mr.
year's hat. Like,
You guys should now have found doubter and dinner, and you should have simplified if it was possible.
that was for your other class that's listening to this video now.
All right.
Mr. Sino, when you should make those hats for like all different occasions.
Yeah,
Like, can you please wear one on my? Can you make one for me on my birthday?
Just for RuneScape?
Yeah, matching.
We'll talk about it later. Joy, Joy, give us the answer. What's doubter?
Negative
But we could do it for,
12x
like
raised
happy
to the
birthday,
power
it's my birthday, then
of
like
3
whoever could wear it. Like,
parentheses.
Raised to the power of what? Another 12x to the power of 3, is that what you said?
Yeah.
And then we'll embarrass people.
And then parentheses 2 minus 3x. Raised to the, oh no. Raised to the power of 4. And then parentheses 1/2.
This raised to the power of 4, is that what you said?
No. The 3x raised to the power of 4.
3x to the power of 4.
Oh wait. I think I did that wrong. Well, no, I did. Okay.
I
Then
think that's
just
when she
1/2.
simplified.
To the power of 1/2?
How did you get to negative 12x to the power of 3?
Yeah.
Yeah, because for me it was a negative 1/2 in front of the first one.
I'm very confused.
Maybe we'll go back a step, but I'm gonna go ahead and select this all to paste it back to see if we got the right answer. So I'll save that for later. Can we write it out, doubter and then dinner, and then we'll check if we got Joy's simplified answer? What did someone get for doubter?
I got negative 1/2 times 3x to the 4th power
Minus 1.
to the
3x.
minus 1/2 power.
Oh, my 4 is a little bit wonky there. 3x to the power of 4,
Wait, how did
all
you
that
get
to the...
3x?
You said negative 1/2 or positive 1/2?
Negative 1.
Negative 1/2, okay. So that's doubter. Do you guys agree that that's doubter?
Yeah.
Yeah.
Okay, what's...
Wait, but wouldn't it be negative 12x to the?
To the 3rd power.
Oh, so you're doing dinner now, right?
Yeah.
Okay, so what's dinner again, Kaylin? Multiply this by dinner.
Oh wait,
What's Nate?
So dinner is. Oh, okay. Okay, so dinner dinner is 2 minus 12x to the 3rd power.
2 minus 12x to the 3rd power, like that?
Yes.
How is it 2?
Wait, what?
Or do you just keep
You
the
keep.
2 or?
Don't you get rid of the 2?
You... I don't know, do you guys?
You
Yeah.
get rid of the
Yes,
2.
there's no 2.
There's no 2? Okay, so it looks like that?
Yeah.
Okay, I agree.
There's a parenthesis. Okay.
Perfect.
Sophia.
So simplify this now.
Oh,
So then multiply.
So it's 6.
it's 6 out of
6x cubed,
Correct.
parentheses 2 minus 3x to the 4th,
Not better.
parentheses to the negative 1/2.
Negative 1/2.
Woo!
All right, cool. And thank you for simplifying. What's another way of writing to the power of negative 1/2?
Huh?
What's another way of writing to the power of negative 1/2?
Put it under
X
the
squared.
Or you gotta put it
Or my
1 all over or 6.
Do a
x
square
third.
root.
Fraction.
No, fraction.
Oh, fraction.
Whoa.
Oh.
Okay, I'm gonna...
Technology.
Oh gosh, come on now. I want to select all this, move it over
I
here.
just wanted to show us the cool tree.
It's like, look guys.
So you want to say that this is equal to, as a fraction,
6x third
6x to the power of 3
all over.
all over
2 minus 3x to the 4th.
3x to the 4th. Okay?
And then to the positive 1/2.
To the positive
But I
1/2.
thought our point was to not make it a fraction.
But that was
Yeah.
only the quotient.
We only want to get it out of a fraction so that we can take the derivative.
Oh, right there.
So it's better to keep it in a fraction after.
So this isn't, you don't have to, I mean, this answer right here is fine. This answer is done. I want to show you guys all the forms that you might see on the multiple choice.
So these are 2 different ones.
Rosalie, don't do that.
And then the first one you get it out of a fraction, and the second one you get it out of radical.
Yeah, you need to get out of radical form or out of a
Oh,
fraction
okay.
form in order to take the derivative. That's a good way of thinking about it. What's another way to write the denominator?
Like, you look really pale. And your eyes
Yeah,
are
you
like
look
really
really-
big.
Square root everything?
Yeah.
Square root like that?
Yeah.
All right. Yeah, so guys, these
See, you
are
can do a square root.
the 3 forms
You guys just yelled at me.
that you can find.
Here,
No.
take it.
No.
Please.
No.
No.
All right. Are there questions before we go to the summary?
No.
No.
No?
Wait, can we all say like a couple words of wisdom for our future students?
We'll do that for another activity.
No.
Stay
All right.
young forever. Don't waste your. I'm just
Thank you.
Oh, yeah.
This concludes the
Don't
video.
waste your